Hey everyone, first off, before I start, I haven't said this in a while, so I want to say that I hope you're doing okay, I hope your family is doing okay, and I hope that you're taking care of yourselves. Today, we are going to look at uh, angles in circles and how they connect to the arc of a circle. And the one we're going to stick to for this week is looking at a central angle. A central angle is exactly what it sounds like. It's the angle at the center of the circle. And it forms an arc which you can trace around the outside of the circle. So the angle of a central angle is formed by two radii. Radii is the plural of radius. So that is this angle. So that the vertex is at the center. And what it forms is an intercepted arc. It forms an arc around the outside of the circle that matches the measure of the angle. So if this is 82 degrees, then this is also 82 degrees. A couple bits of notation that you need to know. When we talk about arcs, this is arc AB. There's a little arc symbol above it. It means we start the arc at A and end the arc at B. That's the notation for it. Now there's another way we can go from A to B, which is to go start at A and go the other way around the circle all the way over to B. And so we need a way to tell the difference between these two. Well, what we do is we introduce a new point, let's say point C, and we say that this is arc A, C, B. So we use three letters instead to say that we still start at A and end at B, but we pass through C first. So A, and then it's got to go all the way around and hit C before we get to B. So that's how we tell them apart. And this arc here, the larger arc that has to go the longer way around the circle, is called a major arc. And the smaller arc that only has to go the shortest distance that would connect A to B is called the minor arc. So that's a little bit of vocab and notation. And again, the angle and the arc for a central angle are going to measure the same. And so first question to pose is, what's the measure? If we have the minor arc and it's 82 degrees, what's the measure of the major arc? Ponder that for a second. And the answer is that, well, all the way around the circle, if I went all the way around the circle, that would be 360 degrees. So the measure of arc ACB, since all the way around is 360 and the rest of it is 82, we can just take 360 minus the 82, and that will give us the other measurement. So that's going to be 278 degrees. That would be the major arc. And this idea that all the way around the circle is 360 degrees is going to be important for us. It's going to let us come up with other measurements based on measurements that we know. So let's look at some examples of that. The nice thing about these problems is that there are a few different ways to tackle looking at this. And I'm going to talk about one of them in particular, just one way to go about this. First of all, we have this angle here being 42, which, by the way, is going to mean that the arc here is also 42. Right? The angle and the arc are the same. So if we're talking about the arc, we can look at the angle. If we want to know the angle measure, we can look at the arc. Now, the measure of the angle across from it, which is over here, those are vertical angles. And we know that vertical angles have to be congruent. So this is also 42 degrees. So there's one of our angles. We got two angles left to find, and we can find them a couple different ways. What I'm going to do is I'm going to draw one of the diameters, which is P to R. I know it's a diameter because it says it's a diameter up here. And that means that this marks halfway around the circle. Halfway around the circle. So if I trace out the arc that's formed from the diameter, then halfway around the circle, well, 360 is all the way around the circle, so halfway would be cut it in half, and this would be 180. All the way around would be 180. And hopefully that makes sense, because this would be a straight line. The straight line would measure 180 degrees. So this entire arc should total to 180. Well, I've got 64 here, and I've got 42 here. So to get the rest of the way, we're going to say that the 64 and 42 and this other arc T to S that we don't know, this is what we're trying to find, has to total 180 degrees. So we're going to combine those like terms and solve. And when we do that, we should get x to be 74 degrees. So this ends up being 74, T to S. Now, the only one I have left to find is Q to R, this arc here. Well, I can do that with a couple different ways, but I want to point out that you can look for other diameters. So I can do it with the same diameter P to R. I could also do it with Q to S. It's going to turn out the same way. So here's another diameter. And we have 42 here. And all the way around should be 180. So if I want the rest of the way, then I'm going to take 180 and subtract the 42 we have already. And so that's going to be 138 degrees. And this is the measure of arc Q to R. So now I can figure out some of the measurements that we're looking for. I'm going to work from bottom to top to figure these out. So let's go P to Q. Well, P to Q is this one up here, and we already know that's 42 degrees. We have P to S. Well, P to S is from here traced out to here. So that's going to be, I've got 64 here. And then I've got another 74 here to get all the way around to S. So 64 and 74, that's going to be 138. Oh, and that should make sense because it's vertical angles with this angle. So they should both be 138. Now, last one, TPS. Ooh, 3 letters. That means we're looking at a major arc. That means instead of going from T straight to S, we're going from T and we have to cross through P and then go all the way around to S. This is the major arc that we're looking for. And what you can do is the same thing we did here. We can combine the angles that we have. We got the 64 and the 42 and 138 and the 42, and we can add those together. Or we can subtract. Because essentially what we want is everything except the part that goes from T straight to S. So we want to go all the way around the circle, 360 degrees, all the way around the circle, except we don't want T to S. So we're going to subtract off the 74 that we don't want. And that'll give us 286 degrees. And so that's all our measurements. So you can see that we're going to use a few different things, but a lot of what we're going to use is going to be combining things to make 360 degrees, working all the way around the circle, or looking at diameters where we're going halfway around the circle. Those are our main tricks, aside from just adding together measurements. Now let's look at an example where we're solving an equation. Like I said, look for places where there are diameters. That's the thing that's going to help you. So for example, I have a diameter here. This is a diameter. So this tracing around the circle has to be 180 degrees. So if I add these measurements up, I have to get 180. So that means I don't know what this is yet, but whatever it is, if I then add 7x plus 9 and add 63, then I should get 180. So if I add this, this, and this, I should get 180. And so see if we can use something to figure out what this is. Pause for a few seconds and see if you can find how we're going to get this measurement. Well, the easiest way is that we can find another diameter. Here's another diameter. And so if we want this measurement, well, this way around should be 180 degrees. And then we have 121 degrees taken up here. So the rest of it should be 180 minus 121, which gives me 59 degrees. And so 59 goes here. So I take the 59 and the 7x plus 9 and the 63, and that should add up to 180. And now I can solve my equation. And as always, we can double check our answer that we get. If x is 7, we can plug in 7 for x into the equation. This is 7 times 7 plus 9. So we have 7 times 7 is 49 and 9 is 58 degrees. So our equation says that if we add these three parts, the 59, the 58, and the 63, we should get 180. Another way you can double check is by saying, oh, this is 59. You can use the same argument with the diameter this way to say that this is 59. And when I add all of these together, so I have 59, 121, 59, 58, 63, that should all add all the way around the circle to be 360. And those are the two most common equations and ways that we're going to solve things. Is to figure out, oh, look for diameters that are halfway around the circle, and look for going all the way around the circle. If you can go all the way around the circle, then all those measurements should add to 360 degrees. Those are the most common ways we're going to solve for things. But sometimes it takes playing around and looking for different arcs that we can put together and combine. All right, that's all for now. Hopefully that should help you get started on the homework, and I will talk to you next time. Take care.